Okay, everyone, welcome again to our instructional session for physics for period 7. I know a lot of you aren't able to sign into these meetings, so this video is being recorded to help you understand the presentation. The presentation will also itself be added to Google Classroom for you to view. But I do have some of you connected to Pear Deck. Thank you for signing in. And I want to know what you are looking forward to during spring break. Today is the last day before spring break. There is no online school tomorrow or next week. We will come back to online instruction on April 14th. Okay, let's see if anyone wrote in what they're looking forward to. Yes, so someone said they're looking forward to catching up on assignments and learning how to get used to this routine. Yes, this is a very, very new routine and it's a lot to get used to, but it's needed so that we can stay safe. Finishing all the work. I love this abstract design you have here though. This is wonderful. Someone said they're looking forward to more sleep. Yes, sleep is great. I hope you get a lot of rest. It's great for your immune system. And someone said during spring break they're looking forward to, they don't know, but look, you have endless possibilities. So I'm glad that you are looking forward to something that you don't even know of yet. All right. Well, I'm glad you guys are in, and I just want to make sure we have this time to go over some of the assignments in positive physics. So all of your assignments are in positive physics right now. I want to first show you our agenda, and then I'll show you what it looks like online, just so that everyone understands what I'm talking about. So today, we're going to look at how to navigate positivephysics.org. And then we're going to look at some of the questions they have in positive physics and go over those together, such as how to round accurately, how to determine significant figures, how to convert numbers into different units. And then you need to take notes from this presentation and take notes in positivephysics.org. Remember, I said physics is a discipline where you have to live in your notes because it's way too much information to remember. But we give you all the skills that you need, and you're just going to use those resources and those skills to solve problems. So it's a really good workout for your mind. Okay, let me change this to a mouse. Okay. We're going to go past these. So actually, before we start rounding and doing significant figures, I want to show you your assignments ahead of time instead of showing you at the end. So I'm in Google Classroom right now, and I'm going to go to your period 7, so that you can see. And then I'm going to go to classwork. Remember, classwork is where you find everything. I've organized everything by weeks. And you have one folder that says about/resources, where I just put resources for you to help you out. But let's look at our current week, which is week 12, and then look at the assignments that you have there. So I have given you the assignments for positive physics. I have the dates that I gave you those assignments here. And then you can see the due dates next to them. Now, I know these say due today, but if you don't get them done today, do not stress out about it, because I know some of you are still learning to navigate this. But if you don't get them done today, don't worry. But you can also try to get them done before April 13th, like these two assignments here that are added before today. And these are all from positive physics. So let's go there so that we know what this looks like. So when you sign into positive physics, it most likely will take you to Unit 1 speed. This is the unit that we are in. This is what our last presentations were about. And the way it works is that you have a work section, an extra practice section, and an assessment section, and then you have skills. And for the work section, you're graded on completion and accuracy. So you are going to do all the skills here for the work section. You're not doing extra practice, and you're not doing the assessment. The assessments are locked. I haven't given you the assessments. And yes, I see a question. When you finish these assignments, mark them as done. But I can see your grades all in positivephysics.org. And I'll just add those grades in, even if you don't mark it as done. So if you're not done with it by the due date, I'm going to add in the grade that I see in positive physics, unless you let me know that it gets changed. But this is how you navigate it. So let's say there's this one right here is the average speed rule, which is what we went over last instructional session. And then they have notes for this average speed rule. If you open the notes, they'll give you examples, they tell you big ideas, and they give you other links. So you see these links here. This is another link in the notes, which is a reference, and it gives you information like what the variables are, what those units are, what the variables mean, and the equations. And some of this I've put in this presentation just to help you out. But I clicked on notes to get there. And now if I want to see the questions, I just click on where it says completion in that gray box, or your box might be colored if you've like finished it or started it. And then it gives you a question and you are able to answer the questions. It'll tell you if you're correct or not. It has hints and lots of different things you can use. Okay, but do not forget, let me circle it so you can see. Don't forget that you have this option to select cannot be determined. So if they're giving you a trick question and you cannot get the answer for what they're asking you because it's a trick, write in that it can't be determined. That is an answer that you can use. Just want to make sure you know that. Okay. I'm going to go back to my dashboard. And we'll jump back to this a little bit later if you have some questions. Oh, someone says, how many of these questions are we doing? You're doing everything up to complete problems 2, all of these. So actually, let me just jump to that slide so you can see it. Our assignment slide is at the end of this presentation. So this is your assignment slide. So you have to do it. It says presentation problems, but it's really preparation problems. Sorry, I wrote the wrong thing. But these are the ones you're supposed to do. So 1 through 3 were due today. But like I said, you have an extension. I know this is crazy and there's a lot of work coming up. But then the next 3 are due by April 13th. And so you see here, 1, 2, 3, 4, 5, 6. I want completed. So I should see 100% completion. Even if your accuracy is not 100%, I should see 100% completion for all of them. And then it'll help me understand which things we need to go over if I do see that everyone's getting like a similar question wrong. Oh, no. So vocabulary and concepts, you don't have to write those down. The assessment, let me go back to it. So if you go to vocabulary and concepts and click on it, they're actually going to give you questions here. And you're going to answer the questions. So here's an example 1. Describes how fast an object is moving, but not the direction of motion. And you just choose the answer. You can write those down if you like in your notes. Like I said, I would have tons of notes. You should have a nice physics notebook that you're using every time. But for everything that you do, you just click over here on the boxes and it will give you the questions. Good. Thank you for writing your questions in the chat room. And yes, everything is saved, so you can just go back whenever you need to. So you don't have to do it all at one time. You can do some and then go back and do some and go back again later. Good. These are great questions. Thank you for asking. All right. Now let's go and practice some things together just so I can answer some questions. So one of the things that they have you to do, this is part of the embedded math section, the second part. If you want information about average speed rule, I went over that in a presentation from Tuesday. But now I'm helping you with the embedded math section. So in the embedded math section, they talk about rounding in significant figures. So significant figures help tell you which numbers to keep. So like they told you here, they want you to round this to 3 significant figures. And that means you're going to have three numbers that are considered significant. And if the fourth number is higher than 5, you have to round the other number before it up. So this is 8.257, but because they only want three significant figures, it will become 8.26 because you are rounding it up because this is a 7. It's 5 or higher. But at the bottom, if you have leading zeros over here, that means these zeros do not count. So then your significant figures will be 4, 7 in this place where there's a 3. But you have to round it up because the number following 3 is a 9. So it's 0.0474. It won't be 0.0473. When I was grading some work, that was a mistake that I saw often. So I just wanted to make sure we went over how to round. Make sure you always round up if the next number is 5 or greater. All right, let's go to our next part, conversions. So we did conversions at the beginning of the year, but conversions is always something pretty tricky. And so we're going to go over how to do that again today. So in positive physics, they gave you some conversion factors, but I also have those conversion factors in this presentation. But you use conversion factors to go from one unit to another unit. So for example, they want you to answer how many centimeters is 0.89 meters. To answer this, you have to know that there is 100 centimeters in 1 meter, and that's the conversion factor that they gave you. So what you do is you kind of set up a table like this so that you can cross things out. So you put 0.89 meters here, and then you put 1 meter for this conversion factor at the bottom so that the meter at the top and the meter at the bottom will cross out. And you put the 100 centimeters at the top. And then what you do is you multiply, like how it says here. You're going to multiply across the top and then divide by the bottom. So you do 0.89 times 100, and then you divide that answer by 1, which would just give you 89 centimeters. And then if they ask you mile per hour questions, you can write miles per hour in MI/H. And like I said before, if something can't be determined, make sure you write or choose it can't be determined. But make sure you don't ever write a distance as a speed. Distances are in meters or centimeters, or they're in miles, or they're feet, or they're inches. It's never meters per second. Meters per second is a unit for speed or velocity. Here's another conversion set that they gave us. I'm going to choose a different color. So they wanted you to go from 23 meters per second to 51.5 miles an hour. And what they did is, once again, they made this table to help us out. Then they started off with 23 meters over seconds. That's what is another way to write 23 meters per second. And then they used conversion factors that they knew. So they knew that 1 mile is 1,609 meters. And they put the meters here at the bottom because they want the meters to cross out. They're trying to get rid of meters. And now you're left with miles, which is good. Then they use the conversion factors for seconds into hours. 3,600 seconds is the same as 1 hour. And you put seconds at the top so that I could cross out with the seconds that were at the bottom here. So now you should be left with miles an hour. And so what you do is you multiply 23 times 36. So these two get multiplied. And then you divide everything by 1,609. And then that gave them this answer right here, 51.5 miles per hour. Let me erase this before we move on. I'm going to go through another example, and then hopefully you guys can do one. So here are conversion factors. I do not expect you to memorize these. Yes, presentation problems are preparation problems. Good question. I don't know it was late, guys. My brain was not working well. Okay, so conversion factors, I don't expect you guys to remember these, but they are found and you can always have them in your notes. So I see someone was asking about one of the questions and it says that it wasn't working. So let's try to do one of those together, actually. I'm going to skip ahead just so I can see you practice and then we'll come back to this. So let's try to do this question together and then maybe it'll work out. So everybody, you should be able to write on your slides. So let's try this one. They want you to go from centimeters to meters. So they want you to go from 131 centimeters and tell them how many meters that would be. So I have the table set up for you already. I have 131 centimeters here. And what I want you to do is set up your conversion table and then solve for the answer. You can also circle which conversion factor you're going to use to go from centimeters to meters. So go ahead and try that, and then we'll work it out together. Good, I see someone writing it out. Looks good so far. Right, it's looking good. And then you can write your answer in this like pink box over here. Oops, sorry. Let me go back forward. There you go. So remember what the conversion factors are, because I think I am seeing some of the mistakes already and what we need to make sure we do. Okay, so I'm going to show one of the responses from your classmates and how they solve this. So what you have to do first, I'm actually going to circle some things so that you can see. First, you have to figure out your conversion factor, and it's right here. Right here, you can see that it's 1 meter equals 100 centimeters. That's the conversion factor you need so that you can go from centimeters to meters, and that's what they use. And they made sure they put the centimeters at the bottom so that they would cross out. So look, they put centimeters right here so that it could cross out with the centimeters here. With the centimeters at the top, and if it's at the bottom, they get crossed out. Now you're only left with meters. So your answer is going to be in meters. And you see how they put this X here? They're showing you you're supposed to multiply. So 131 times 1 would still give you 131, but then you're going to divide by this number on the bottom. So then it's 131 divided by 100. And that gives you 1.31 meters. And you know it's meters because it's right there. That's the only unit that was left over. Does that make sense? You can write in a chat room and I can try to see if we can do another one. Okay, good. I'm glad. Okay, I'm going to erase some of this. And I'm going to show you a longer one because in the positive physics, they have some longer ones. So here's a longer one that I've already set up and solved for you. And I want to go through how to do it so that you can see every step that I've done. Okay, so the question is to go from 11 meters per second to miles per hour. Now this time I do have meters per second, so I do have units that are divided. So I will use the top box and the bottom box in the first section. So I write 11.0 meters divided by seconds. So this means 11 meters per second right here in the first box. Now, the first conversion factor that I can use is, and you don't have to go in this order, but this is the order that I went in. I found right here that it says I can go from feet to meters. And I'm going from feet to meters first because I don't see how to go straight from meters to miles. But you know what? I could. Maybe I should have just gone from meters to miles by using this. But I made it hard for myself and I did two conversion factors when I could only do one. But let's see what I did. I went from feet to meters. So I found that 3.28 feet equals 1 meter. I put meters at the bottom, and I didn't put the one because the ones don't really matter, since multiplying or dividing by ones doesn't change anything. But I put the meters here so that they will cross out. And I put 3.28 feet at the top. Now, let's see if I can get rid of the feet, because I don't want feet either. So I found that 5,208 feet equals 1 mile. So I put that here. I put miles at the top and I put feet at the bottom. So now I can have both feet cross out like that. Now miles will be left. Yay, because I want miles. But now I still have these pesky seconds that I need to get rid of. So I found over here that 1 hour equals 3,600 seconds. So I'm putting seconds at the top so that I can cross out with the seconds that was at the bottom at the beginning. So now I should be left with miles and hours here. So what I do is I multiply all three of these. All of this gets multiplied. 11, 3.28, and 3,600 will get multiplied, and that will be in miles for the units. And then I have to divide by this number, 5,280, and that gives me this answer, 24.6 miles an hour. And that's a way to do the conversions. And we are just about out of time, so I'm going to stop here. But what I want to do is make sure you don't have any more questions. I'm erasing all of this, and I want to go back to our assignments once again so that you can see what the assignments are in positive physics. And I didn't get to go through all the presentation, but will all be posted in Google Classroom. So these are the ones you're doing. Sorry, it says presentation problems, but it's preparation, which is why I did a screenshot, because that helps a lot better. So you're going to be doing these assignments here. And once again, have a great spring break. Enjoy your spring break.